One of the biggest mistakes you can make when you're building your house is by putting ducts up in a hot, humid attic. On the build show today, I'm going to show you a really smart builder that's doing something that I've never seen before. He's making chases for his ductwork that are inside the conditioned envelope. He's not relying on spray foam. He's doing this very inexpensively. And oh, by the way, he's getting paid $15,000 a house for doing it the right way. Today's build show, Ducts and Condition Space. Let's get going. All right, y'all, let me introduce you to a very smart builder, Charlie with Boa Builders. Charlie, what am I seeing here? Walk me through this.
Yeah, so this is a Rheia duct system inside what we call an inverted soffit system.
Okay, so in other words, this inverted soffit is in effect part of your air conditioned envelope, meaning you're gonna put insulation on top of that soffit, and somehow you're going to air seal that so we don't get a bunch of airflow from the house up there.
Exactly. Yeah, the biggest thing for us being DOE Zero Energy Ready, certified Energy Star Next Gen, and Energy Star 3.2 is we have to all of the ducts inside the thermal barrier.
Which is really smart. We want all our ducts in the air-conditioned space, right?
Yep.
We've all seen houses with ducts running through 140-degree attics. That's really dumb. But now your duct works in the same air-conditioned space as we're living.
Yes, correct. So we'll have an air barrier above that, which we use aerosol.
Okay.
Used to be called aero barrier, now it's aerosol envelope. So we use that above that, and then we'll have insulation above all the ducts as well.
Okay, let's back up a minute. So first, talk to me about the planning, because I don't suspect you just showed up and did this one day. You had to think about this before you started framing, right?
Yes, for sure. We basically work with our truss manufacturer, BFS. We get a preliminary plan with all our trusses. We figure out which way they're going to run, where we want our soffits. I take that prelim plan, send it over to my HVAC company. They do a manual J for me, manual S and D based on those initial soffit plans, inverted soffits.
Yep.
Once they figure out exactly how much CFM in each room, how many outlets we need, I take that back over to our truss manufacturer. They finalize all the designs on the soffit, and then we have this in place is what you see here.
I'll tell you what, I actually came out here with Builders FirstSource. Why don't we go meet Matt, your truss guy, and we can actually see some of that on the computer.
Sounds good.
We'll meet you over there. All right, Charlie and I made it to the BFS Grand Junction location where Matt is his main truss designer. Matt, talk to me about how you and Charlie basically coordinated those super cool inverted recesses we saw at the job site.
Yeah, so he'll give me a set of plans. We'll draw it up. I'll do the truss layout so he can identify which way the trusses are going to go.
Okay.
And then obviously his Monarch HVAC system is going to come in and tell us how many ducts they need to go into each different place, which at that point in time then tells us how big the trays, the inverted trays, need to be.
Gotcha.
And the locations of where those go. So then at that point in time, we'll start going in and putting the trays in and designing the trusses around them to see what can actually work and what can't, and where if we need to move them or not. And then on top of that, there's a lot that goes into it, because when you start doing this, it adds a lot of webbing, right?
Yeah,
so that's going to add a lot of price to it. So we've got to try to go in there and find ways to make it cost efficient as well. And get a little tricky with the webs and not just keep everything as structural, but we can go in, put them in as fillers and different things like that to reduce the cost, but get him all the trays and the truss profile that he needs.
Charlie, this is super impressive. So you and Matt basically got together, and Matt told you, hey, these trusses are running side to side.
Yep.
And then you and Matt together kind of gave Monarch Design a bit of a preliminary layout. But then Monarch did the manual J for you based on your wall thickness, your insulation values, your windows. Is that right?
Yep. Yeah, Monarch does all the manual J, manual S, and manual D for us.
But you kind of generally laid this out for them, but then they did the specifics, including like, I need 48 CFM into this closet, or 115 into this master bedroom, whatever those specific numbers were. Is that right?
Yes. Yep. Correct.
That's pretty incredible. And then you and Matt basically together with Matt's leadership here laid out that inverted truss, so when these come to your job, all those trays, for lack of a better term, are already on the job and ready to go, and they've been pre-planned. Is that right?
Yep. Yeah, we call them an inverted soffit, and that way our framers can just come in, they line it with OSB, and it's an easy fix for it.
That is super impressive, Charlie. Matt, thank you for the tour, man.
Thank you.
Super impressive. This is some really nice work here. All right, so some serious forethought happened. Walk me through the framing process. Now that you've got the trusses designed, all those chases basically were built into the trusses. Matt did a great job on that. So then walk me through how that works with your frame carpenter.
Yeah, so as you can see here on the other side of this, and we'll look at that in a second, is the main HVAC closet.
Okay, so everything's emanating from there.
Yep, so it's a upflow furnace, so we'll have all the Rheia ducts come up into the main chase, which we've sized appropriately for however many chases. As it comes and splits off, you can see the different chases split off here.
Yep,
Will
and
come
so
more
this one then is splitting off to maybe a
room.
hall, laundry
Yep,
room,
got a
hall,
laundry
bathroom.
And this will be the master back here.
Okay.
And so in the manual J, they've determined however many CFM, and so many CFM can go in each register, so we figure out how many registers they need. And then the framers already have those trusses built in, or the chases built into the soffit, so they can use scrap OSB that we have left over from the roof, just half inch OSB.
And how are they sealing that OSB? What's the method to stop the airflow from the house to the insulation that's beyond that?
So as you can see, on the initial air is just a can spray foam.
Okay, so you're just going through literally with a can of foam and hitting those joints.
Yeah, so as you can see, the insulation's already done. So the insulators come in, they hit all their normal stuff for fire cocking around.
And you don't even need to do that before the Rheia duct goes in, I guess,
Nope,
huh?
they do that afterwards. And then kind of the secret ingredient, I guess we say, is aerosol or air barrier. So after drywall is up, we'll cut holes in the soffits if we need to get that aero sealant, the fogged sealant up into those. And so the sealant will be able to go up in there, forces it out any of the
Let me borrow your tape measure. So if we're pointing to this location right here, let's say we've got your OSB coming down. I've got drywall that's going to come in and get hung traditionally. You're not trying to do a sealant between this OSB and the drywall. You're actually using aero barrier to do that seal?
Yep.
Oh, got it. That's fascinating.
So
in other words, you'll cut a hole right here in the drywall during the drywall process and have air barrier come after sheetrock, but before finishing.
Yes.
Am I saying that right?
Yep. Yeah, we put sheetrock up. We'll tape all the seams and all the screw joints. We'll cut those holes. Drywallers leave for a day. Aero barrier we can do in half a day. They come in here, finish or prep all the windows. We can pressurize the whole house. It seals it all. We take a couple hours to do that whole process. Once they go, then
and what are you taking the house down to on aero barrier?
We're trying to, since we're doing next gen, Energy Star Next Gen and DOE, we're usually under a 1 ACH, so 0.8, 0.9.
And where do you typically start? Where are you before that?
We're about a 4 to 5.
Okay.
We can get lower, but a lot of times we're not doing a special, like we're not sealing the bottom plates. I mean,
you're letting aero barrier do that.
Yeah, because aero barrier is going to do it. So why spend all the extra money and time on labor with a couple guys with caulking guns when aero barrier can do it in 45 minutes?
Go check out my video at my house about aero barrier, but the quick basics is we're going to pressurize the house and we're going to do this kind of aerosolized caulking. It looks like a big fog, like it's a foggy San Francisco day inside the house. And the blower door fan is pressurizing the house, so we're forcing that fog of this aerosolized caulk through all the cracks and crevices, including that joint right there in that soffit for his ducts. Let's call it a soffit. It's not really that. It's an inverted soffit, I guess. And that's going to seal all the minor cracks and crevices. I like to think about it like a little elf with a tiny caulk gun getting all those micro joints around the house. And as time goes on, as that fog stays and continually fogs, those beads of caulk that are aerosolized kind of glob onto each other and form a big bead of caulking wherever's needed. So at my house, I went from, I forget what it was, 1.1 ACH 50 down to like a 0.1 ACH 50. But it works well for any size house or any leakiness, frankly. So even a 4 house, which would have been code approved and still is in Texas, you can get down quite low to that, 0.8. Figure, let's say.
Yeah, and that ACH number really helps on the load of your HVAC equipment.
For
So
sure.
a lot of that leakage is based on.
What are your general load calc numbers for a house like this?
This size, these are 15 to 1,800 square foot, and so we're usually a 2-ton unit.
For both heating and cooling?
Yes.
So that's not bad at all. 2 tons of heating that's like 900 square feet to the ton, something like that for heating and cooling. It's not bad at all. It's pretty good. Let's walk out to the garage because I want to show you the HVAC closet as well. Another mistake I've seen over the years that I made myself when I worked in Oregon years ago was we would put a lot of, can you help me open the door here? What's the plan? We'd put a lot of HVAC equipment in garages, and the problem with that is if your HVAC equipment leaked at all inside the garage space, you'd pick up that garage air and send it into the house, which garage air is never the best air to breathe, right? Your car just pulled in, you got some fumes out of the exhaust pipe, now it's pumped into the house. But what Charlie's done here is put a sealed door, all weather stripped. This is an exterior rated door. It even has insulation in the door. Put this inside this closet, drywalled it, and then this will get insulation above as well, and this will get fully air sealed as well. And now this is his Rheia duct supply, and this is his main return, which is in the hallway as well, right?
Yep. The part of that certification program is, yes, just like you said, all the HVAC has to be inside the thermal barriers.
That's really smart.
We've got the return going through another inverted soffit that we determined where it would go. So yes, that's fully air sealed and insulated above it.
That's amazing.
And then yeah, this will be fully drywalled after they're done.
Well done, sir. Is that a floor drain that I'm seeing there?
That is a floor drain.
So you'll put a pan in here too?
Yes.
Oh, that's awesome.
Yeah, we'll put a galvanized pan. It'll drain down, and then we can also drain the hot water heater, which are all heat pump hot water heaters as well.
Fantastic.
And then if there is any kind of leakage, the new A.O. Smith hot water heaters have a water sensor. And we can place in the bottom of the pan, so if there's a leak,
cool.
it can turn stuff
You don't have
off.
another house that we could see that would be a little more finished this one, do you?
Yeah, we've got one that's almost done next door. We can go check it out.
Let's meet there. We'll finish up the video. All right, Charlie, here's your terminations. These are basically your registers or grills that are going to go on these either circular or linear ones. How do these work? They don't seem to have any adjustment on them.
No, these are just the grill, I guess you'd call it. And so this is a wall register, this is a ceiling one. And if you can see up inside of there, each of those will have its own damper. So there's
Okay, so that little flap I'm seeing is a damper right there.
Yes. So that's a 5-position damper. It can go from 0, which is all the way open, to 5 all the way closed.
Okay.
So during our design, we know how many CFM is supposed to come out of this.
Yeah, we saw that in Matt's office.
Yeah.
Your design had like 45 CFM in this room or whatever.
Yep, and so at this stage, we'll come back in after it's fired up. We'll use a flow hood. They test every single one. We can put the actual CFM into the computer software of Rheia, and it spits out what the damper should be. So it might be a 1. Theoretically, if it's all correctly installed, they'd all be at a 0, and you'd get those CFM numbers.
Gotcha.
But if we need to tone one back, add one, so they'll adjust all that, and now it's completely.
That's pretty neat. So this is just a dummy, right? This is just for looks, but the brains are up in the ceiling, and it can be commissioned all at the end of the project.
Correct.
So in other words, I'm not worried if my Rheia duct is 15 feet when it was supposed to be 19 feet or whatever.
Exactly.
I'm able to do that later. Or conversely, I have a client who says, hey, I'm a little hot in this bedroom. We can come back and adjust that and add some more flow there.
Yeah, one of the problems in our old systems when you have an attic system with just a regular insulated duct is the damper to control that is up in the attic. So what happens then, we have to find you go up in the attic, you tramp across all your insulation, you smash it down, you're never gonna get it back. Now all of a sudden you've got 2 inches of insulation when you should have had 12, something like that. So yeah, this can all be adjusted from down low.
Gotcha. Let's go see the mechanical closet. We'll actually show you what the equipment looks like. All right, beautiful finished house, but of course I gotta see the mechanical closet first.
Yep, here it is. So we'll get in here.
So we're in the garage, and again, this is just like the house next door where you've got a sealed mechanical room door. So in other words, all this equipment is within the conditioned envelope.
Yes, yep. HVAC unit and heat pump hot water heater, both inside the thermal barrier.
So traditional upflow unit, this is nothing super expensive. This is a heat pump. Even though we're in a cold climate, you can make a heat pump work down to 0 or maybe -5 out.
Yeah, this is there's certain heat pumps. This one is certified for cold climate, which means it's certified to a certain percentage down to -5.
That's amazing. You got a good filter here. So this is the return side, and then that's the Rheia duct supply.
Yes.
And then interesting, you've got a heat pump water heater in the same closet.
Yep, heat pump hot water heater. Of course, again, we don't want it we want it inside the thermal barrier.
Yep.
So all we have to do is duct the intake and the exhaust on that.
Gotcha.
So we've got exhaust going outside. I don't know if you can see the energy sticker on that. That's $120 a year.
A year, that's it.
For everything. There's
compared
no gas
to a
to it.
standard electric, which would be 500.
Or more, probably more like 800. Gas is $500-600. So yeah, $120. That's it.
That's
for the whole
awesome.
year.
I'm also noticing this is your pan, so that's probably got a drain like your house next door has.
Yeah, we got a galvanized pan on the bottom. The A.O. Smiths also have a sensor, and it's not hooked up yet, not we're fully done, but it'll hook into the control system, and it has a little water sensor in case there's a leak. It'll sense that and have an alarm that goes off.
That's awesome. The biggest thing I notice here is that there's nothing crazy. This is kind of normal upflow 2-ton equipment. This is probably 800 CFM. It's not like a high velocity system. This is kind of normal HVAC equipment.
Yeah, up until about 2 years ago, this would have been open to the garage. Same style system. We've used York, we've used Bosch. We're now on an Amana just because of the efficiency on them's better. But yeah, nothing special on them.
That's fantastic. Love it.
Trying to keep costs down as much as possible.
Now you got a tight envelope, so I'm guessing that this guy right here might be helping with us when it comes to fresh air, isn't it?
Yeah, that is a Brown ERV. We're an ERV climate.
Yep.
And so we've got fresh air. This is running 24/7, so 24 hours a day. It's running right now and you can't even hear it.
It's pretty quiet. And so this guy is going to bring the fresh air in. And are you pulling out of special places like a master bath or something
exactly.
like that?
We're actually pulling out of all the bathrooms.
Okay.
So we're pulling all the stale out of the bathrooms, and then exhaust it right outside.
And where are you supplying to from this thing?
It dumps into the return supply of the HVAC system.
Okay,
so
that's
the
cool.
HVAC's not running; it's coming out the.
So it's also tempering it on those coldest winter days.
Yes.
And you're not dumping that cold air necessarily into anywhere. But an ERV is going to be able to mix. It doesn't actually touch the air, but it moves the heat and the humidity between the.
Two air streams. I explain it to customers almost like a radiator in a car.
Yeah.
So the water inside the radiator is not touching the air outside. So same kind of principle.
Yep.
The air's coming in and going out, but it's not touching each other.
Gotcha. All right, before we finish the video, Charlie, we said at the top of the video that we were going to explain how a builder could see up to $15,000 back in their pocket by doing some of these things. Can you explain that to us?
So two different pockets of money, I guess, we're accessing. One is the $5,000 tax credit from the 45L Inflation Reduction Act. And if that's every house that's net zero ready, so DOE Zero Energy Ready certified, we get a $5,000 tax credit.
And that's direct to you as the builder.
Yes, that's a builder credit.
That's huge.
And then our local energy providers, Excel Electric, and they're actually in multiple states. I think they're in 12 or 13 states. They are doing a $10,000 up to $10,000 rebate for Energy Star Next Gen and Energy Star DOE. You have to be on the current system of that, but that's $10,000 per house.
And what's the HERS rating on a house like this?
Pre-solar, we're about 40 to 42 on a single family detached unit.
So it's twice as good as code.
Yes.
And oh, by the way, these are not super expensive houses you're building, are they?
No, we're in the mid 400s here, which is pretty standard for our area. We're able to do a lot of those things like you mentioned earlier with spray foam in the attic. We'd be adding $10,000 to $20,000 a house, and so we're able to use a lot of these, I guess that you would call more affordable solutions to be able to get a house down to those HERS scores. We can put a small solar system on and get them down to net zero.
To net zero, a zero electric bill at the end of the year.
Yep.
Charlie, I love that line. I want to say that one more time. We're using more affordable solutions to get to a really high performance house. Charlie, very impressive.
Thank you.
Thank you so much for the tour. Big thanks to Builders FirstSource for bringing me out to meet you. We've been hanging out with BFS and a bunch of their customers here at Grand Junction, Colorado. We shot a whole nother video with those guys. Go check it out. But I felt like you guys needed to see this ducts in the conditioned space. I'll put a link to Charlie's company in the description below. If you're in Grand Junction, you should be buying one of this man's homes. And if you're a builder in another part of the country, steal his ideas, because there's no new ideas, right?
No.
And do this in your market, because bringing your ducts in the conditioned space makes a huge difference, not just in energy efficiency, but in comfort, in durability, and indoor air quality, and the health of your clients, which is what we really care about. Because ultimately, it's great to save $100 a month on your electric bill. But what's really great is super healthy air, no duct outside of the conditioned space, none of the other bad things that happen with microbial growth when that happens, none of that other garbage in your house, really good indoor air quality. It's a very smart builder. I appreciate you having me out. Guys, if you're not currently a subscriber, hit that subscribe button below. We've got new content every Tuesday and every Friday. Follow us on Facebook or Instagram, otherwise we'll see you next time. You know how I close my videos, right? On the Build Show.